as you graph, you'll come across some examples that ask you to graph horizontal and vertical lines. Horizontal lines are lines that are straight across with no rise or slant in them, and vertical lines are straight up and down with no slant. Each of these types have a very specific equation. You're going to notice that all horizontal lines actually are going to have an equation where y equals some number. And as I show you some examples, you'll see why that happens. The vertical lines are always going to have the equation x equals some number. Let's look at some equations and figure out how you could determine whether or not they would end up being a horizontal or a vertical line when you graph them, just in case you forget this idea. Let's take a look at the equation x equals 3. This equation is going to be graphed in a linear coordinate system, but you notice it looks different because it does not have a y value. This is actually the same equation as saying x plus 0y equals 3. However, we don't usually write it that way because saying 0y doesn't really have any value. When you look at graphing by picking points, I want to choose some points for x and y so that it matches the condition of the equation. Where is x going to be 3? Well, what happens here is that you find out it does not matter what you choose for y, because if you see over here, whatever you would choose for y, you'd end up multiplying by 0. The x value in all of my ordered pairs has to be 3 in order to meet this condition, x equals 3. So it doesn't matter what values you choose, they're only going to fit the equation if you choose where x is 3. Y can be anything. If y is 0, x has to be 3. If y is 5, x has to be 3. If y is a negative 10, x has to be 3. It doesn't matter what values you pick for y. So when you go to graph this, draw my y-axis and my x-axis. X equals 3 is the point right here. There is 3, 0. There's 3, 5. And 3, negative 10 is going to be off my paper down here. But you can see that all of these points where x equals 3 are going to fall on a vertical line. Let's look at an equation where we have y as some value. For instance, y equals a negative 4. Again, there's no x in this linear equation, but I could have the equation 0x plus y equals negative 4. What I'm saying is that no matter what value I have for x, my y value has got to be equal to negative 4. So if I solve this by choosing points for x and y, I can pick anything that I want to for x. I could let x be 0, but y has got to be negative 4. I could let x be 3. You let x be negative 5. Doesn't matter what values you pick for x, your y is stuck at negative 4. So when you go to graph this, I'll let this line be my x-axis, let this line be my y-axis, and then I'm going to choose some points that match this condition so that I know y has got to be negative 4. So here's the point 0, negative 4. Here's the point 3, negative 4. And down here is the point negative 5, negative 4. And you see that all of those points end up falling on this horizontal line that crosses down here when y is negative 4. So as you learn to solve these, you could actually pick points, or you can remember that every time you graph, if the problem starts out x equals some number, then the graph is going to be a vertical line. If the problem starts out y equals some number, then your graph is going to be a horizontal line.